Section 1.2 is on scattergrams. We're going to start by talking about independent and dependent variables. Assume that a situation can be described using the variables t and p, and that p depends on t. If p depends on t, t is going to be independent, while p is the dependent variable. All right, let's look at a couple of examples. All right, in each situation, we're going to identify the independent and dependent variable. So in the first situation, we have n being the number of words in a document, and t being the number of minutes it takes to type a document. Well, how long it takes you to type is going to depend on the number of words. T, the number of minutes it takes you to type, is going to be dependent, while the number of words in the document is going to be independent. In part B, the length of a person's hair in inches is at t weeks since the hair was cut. Okay, so the length of your hair since it's been cut, the length depends on how long it's been since it was last cut. The length depends, so length is the dependent variable, and t, the amount of time since it's been cut, is the independent variable. And part C, let h be the height of an object that is dropped from a building t seconds after it was released. So you can imagine if you got your building and you're dropping an object off of it, the height at which it has fallen to is going to depend on how long it's been since you dropped it. Height depends on the time. Height is dependent on time. Time is the independent variable. All right, definition below. An ordered pair is a pair of numbers of the form x, y, where the first number is the independent variable called the x-coordinate, and the second number is the dependent variable called the y-coordinate. Now notice when you're looking at ordered pairs, it's always in the form x, y, always in the form independent then dependent. So when I'm identifying what is independent and what is dependent, I'm often finding the dependent variable first. The dependent depends on the independent and helps me get that relationship. But the dependent variable is the latter coordinate, the y-coordinate, always the second position. Independent variable is always first. So even though I might figure out which one is dependent before I figure out which one is independent, when I write them in an ordered pair, it's always of the form independent, dependent. Let's look at example 2. The revenues for Google are shown for various years in the table. Which variable is independent, which variable is dependent? All right, well, the amount of revenue that they're going to make is going to depend on what year it is. Let's try that in reverse. Does what year it is depend on how much Google makes? No, right? The amount that they make depends on what year it is. Okay, so the independent variable is going to be, the year, and the dependent variable is going to be the revenue. Let's list the ordered pairs that correspond with this data. Okay, so the first set of data is 1999, comma, 0.2. The next is 2000, comma, my commas aren't sticking, there we go, 19.1. All right, and continuing on, just list all the ordered pairs. Now, those would be the ordered pairs that correspond with that data. The ordered pairs are listed in the order of independent, dependent variable. When we plot points that are not being used to describe authentic situations, we call the horizontal axis, horizontal right here being the x-axis, and the vertical axis, the y-axis. In this case, x is the independent variable, so we always have our independent variables on the x-axis, and y is the dependent variables along the vertical axis. Okay, so other labels to fill this in. Other labels are the origin is this point right here in the center, the place where both x and y are 0. Now we've got 4 regions, 1, 2, 3, and 4. These are our 4 quadrants. So we'll have quadrant 1 in Roman numerals. We'll have quadrant 2. All right, quadrant 3 and quadrant 4. I'm just going to use a Q for quadrant. So quadrant 3 and quadrant 4. All right, and the order of the quadrants kind of forms the shape of a C, just to remember what order these are in. Quadrant 1, 2, 3, 4 goes around this direction. Let's look at an example of plotting some ordered pairs. All right, there are several ordered pairs here, and our directions are to plot them and label them. Okay, so let's plot the first one. This ordered pair is 2, 8. So remember, the order is always the x direction, then the y direction. So starting at the center, in the x direction we need to move 2. Don't draw anything yet before going 8 in the y direction. Now we're going to draw our dot for an ordered pair right here. Okay? And we're going to label this one A. Okay? Next, let me just make the thick line right here. Let's see if I can get this to draw better. Next, it's 8, 2. So 8, 2 is going 8 in the x direction, 2 in the y direction. Okay, and that's going to be our point B. Okay. C, I'm going to change my thickness one more time. 4 in the x direction, negative 2 in the y direction. I'm going to need to scroll down for this one. Okay, so 4 in the x direction, negative 2 in the y direction. I'll put it right here. D, negative 1, 3. So negative 1 in the x direction, over this way, up 3 in the y direction. So right here will be the point D. Changing my thickness again, and let's keep going. All right, so E, negative 5, negative 2. Negative 5 in the x direction, negative 2 in the y direction. Be right there. Okay. E, F is 0, 7. So 0, 7, we're going to move 0 along the x direction, which means stay in the center, then up 7. So that was where F would be. G, 4, 0. 4 in the x direction, 0 in the y direction, so it's going to stay right on the x-axis here. And G, finally, negative 1 in the x direction, negative 2.5 in the y direction. So it'll be somewhere between negative 2 and negative 3 in the y direction, so we'll just draw our dot right there approximately in the middle for H. Alright, in example 4, determining the meaning of an ordered pair. Let n be the number of words in a document, and let t be the number of minutes it takes to type the document. What does the ordered pair 400, 8 represent? So I don't know if 400 is words or if it's minutes. Before I can figure that out, I need to know if the number of words is independent or dependent. Okay? So I know that the number of words in a document is going to change how long it takes to type. So how long it takes to type the document will depend on how long it is, right? So this is going to be dependent, and the number of words is going to be independent. All right, so that means that what comes first, our number of words, is independent. That's going to be our n. And what comes second is our dependent, our number of minutes. So what we can say is it takes 8 minutes, that's our dependent variable, to type 400 words. B. Let L be the length of a candle in inches at t minutes since the candle was lit. What does the ordered pair 36 represent? Well, the length of the candle is going to depend on how long it's been. So you know it's going to get shorter the longer it's been lit. So the length will depend on how long it's been since it was lit. So that'll be independent. Independent comes first, so that means that independent is 30 minutes, and the dependent is 6. So when the candle has been lit for 30 minutes, it is 6 inches long. The independent is 30, the dependent is 6. All right, next we have the subject of scattergrams. A scattergram is a graph of plotted points that shows a relationship between two sets of data. So in this chart we can see our Google revenue and the year. So I want to take a second to graph a scattergram of the data. We're going to need to make sure that we label our axes appropriately. Now, T is going to be, in this case, years since 1995. There's no way I'm going to be able to fit 1,195 on a scale up here. So often when I have years, I measure years since a certain value. So T will be years since 1995. So in the first case, we have 4 years since 1995, 5 years, 6 years, 7 years, and 8 years. Those are the values we'll need for T. Revenue. We're going to need to use these values for revenue. So we're going to have a very large scale to be able to compass numbers all the way from 0.2 to 961. So think about scaling on both of these. Okay. Now, T is independent. Independent variables are always along the horizontal axis. So my independent label is going to be T, years since 1995. My vertical axis is going to be R, revenue. A good labeling system for T would start at 0, 1, 2, 3, and so on, because those increment by 1 each time. The years increment from 1 up to 8, so I know I don't need to go much beyond 8. I'll just go to 10 on my labeling. And a scaling system for revenue might start with 0, again, because I need to have something small enough to encompass the smallest point and large enough to compass the largest point. So if we start at 0 and go up by 100, we'll be able to fit in 961. So we'll start with 0 all the way to 1000. Now let's graph the ordered pairs. The first ordered pair is 4, 0.2. So 4 years since 1995. 0.2. So it's going to be very, very close to 0 right here. The next point, 5, 19.1. So 19.1, if you think about this, halfway up is 50. A quarter of the way up is 25. So it's just below a quarter of the way up. So let's draw that dot in there. Next is 686. So if you think about where 86 should be, halfway is 50. 3/4 of the way is 75. So a little bit higher to get to 86. Next, at 7 years since 1995, we'll have 347. So 350 would be halfway in between, so just a tad below half. And lastly, 8 and 961.9. So a little bit above halfway from 900 to 1,000. And there we have our completed scattergram. All right, let's check out the next example. Is there a relationship between education and prejudice? Suppose that a psychologist gathers a random group of people to study the issue. For each person in the sample, she records the number of years of school and their score in a standard psychological test measuring prejudice. So we're going to create a scattergram of this data, looking at years of education versus prejudice. The years of education are going to be our independent variable. So our assumption is that the score in the prejudice test will depend on how many years of education they have. The horizontal axis will be our independent axis, so X, years of education. The y-axis will be the score in the prejudice test. All right, some of these values. We've got 12, 1. All right, so just kind of getting an idea of the range here, 12, 5, 14, 13, up to 16, down to 4. We have to probably number these 1 through 16. And on the y-axis, our scores need to go all the way from 1 up through 10, so again a scale of 1 will be appropriate there. And let's go ahead and graph some of these. So the first one is 12, 1. The next one is 5, 7. I'm just using an X because it's easier to make than a dot on this piece of software, but a dot is what you would use on paper. And let's continue to graph the rest of these. And this is what the completed graph should look like. Alright, now it's also possible to graph a scattergram on the calculator, so there are directions in your course path that you can follow to graph in the calculator or in Excel. Final topic. A bar graph is a diagram with 2 or more axes that can be used to compare measurements of 2 or more items. In example 6, the number of visitors to ski resorts are illustrated in the bar graph below. So we've got millions of visitors as this vertical axis, and our horizontal axis is identified by each of these regions that are listed. For which region is the number of visitors the highest? So the number of visitors is the highest and the tallest of these bar graph objects. So for the Rocky Mountains, 20. For which region is the number of visitors the least? It's the least in the southeast. And what is that number? That number seems to be about 5 million. And last, let's estimate the number of visitors to ski resorts in the Midwest. So in the Midwest, this number, let's try to trace it over. So if I draw a line, it's just under halfway, which would be about 7 million visitors. That's it for this section.